used by Einstein for theory of relativity. So that's why I have heard everywhere. Basically, there are two types of tensors: contravariant and covariant. These are two types of tensors. One is covariant tensors, another is contravariant tensors, and these both are defined according to some reference of frames. The change of reference frames, these are defined according to that. That's why it's all goes with reference frames. But it's not related with my paper, so I didn't went into deep theory.
What is the actual application for? I mean, the application
Of,
in communications for this
tensor.
tensor.
Yeah, that's what I'm going to discuss. The thing. First of all, if I ask simply what's the use of vectors, so vectors can, in mathematics, vectors is represented by, we have some space for the information. Okay, suppose we need more information into the same quantity, then what we have to do, one quantity is defined by m by n matrices. We can put more information here. This is vector, this is tensor. Tensor is nothing but higher degree of vector. That's why we are using tensors. I'm not talking specifically, I'm just giving an idea that suppose we need more information in the same thing, then we use tensors. Because in vectors, we just have 3 components. In diad, we have 9 components at a time. So we can, at a time, we can put more information. And that's the reason why they use a tensor for representing one pixel. Like this is my picture, okay? Whatever is the picture. So every pixel is represented by n matrices. And that matrices is a kind of, you can say, this is a tensor. So what the author is trying to do, each pixel of the image is converting into a tensor. Tensor means a matrices here, because if you use second degree means rank 2 tensor. Rank 2 tensor means m by n matrices. That's his goal.
No, but is it useful for compressed sensing, or I mean, which because like here you were saying that it is being used for like a lot of you can talk about a pixel being in different things, right? A lot more information about a single pixel.
Okay.
But
let me discuss. For example, suppose one point is there. Okay. Can you give me another pen, please? What information it can take, which is useful for us? Its XY coordinates, its intensity, brightness. We can imagine more than that. So how XY coordinate can be put in a vector? Okay? Point is one. We can't take 2 different points for it. So we have to put something so that the whole information of this point comes into this one. If I will use vector, I can cover only x and y. But I have to put intensity, I have to put brightness. So what I will take? I will take 1, 2, 3, 4. So you can think of say one position, intensity and brightness, these 3 information in a tensor of order 3. I'm trying to explain. This is not exactly what I'm going to do. I mean, did you get the point? It's a discussion. I want some questions so that why we are using tensors. So and what will be the application? When we just need 2 information like x and y, we can use a vector for xy information. But suppose there is a pixel who has some intensity, who has some xy position, who has some brightness, and we all have to put in one thing. So in vectors we have only magnitude and direction, but in tensor we have multi-dimension. So you can put all the information in one tensor. So all the point here will be converted into tensor, so that we can put lot of information here. And that's the reason why we are using tensors. So, any question about tensors so that I can start tensor voting? The rest of the part I have discussed a lot in the previous class, but I will try to make you understand so that I can get a partner who can discuss with me a lot.
Finding a partner these days is really difficult.
Yeah, I know.
Research partner, what kind of partner?
Tensor voting. Tensor voting, as I told you, is nothing but like you are receiving a picture, an image. And what you will do, whatever image you are getting, if you will convert each token into a tensor, say tensor 1, this is for tensor 2, tensor 3, tensor 4, okay, then you will get a group of tensors. What they will do, because this the image you are receiving from some communication channel, you are receiving from a binocular, so it may be possible it comes with lot of noise. So each point has noise as well as some data. So what they will do, this pixel will make a range. In this range, whatever points comes, they just interchange the information in form of tensors. Okay? Like if this is the center point, it will give its tensor information to this point and this will give to this one. So the center point will receive tensors from all the points which are neighbors to it. And when it will receive the information, this tensor becomes, you can say, more populated. When it becomes more populated, it will get more information, and with the information, every tensor, if you look at tensors, each, and in an image, you can have a line, you can have a point, you can have a surface, you can have some curvature. Every tensor has, if you look at tensor, you will say, oh, this can be a curve, this can have a point, this can have a ball. So every image has a particular tensor. So by looking at tensor, you can check whether it has what is the feature extraction, whether it's surface, curve or point. So by using that tensor voting, the tensor at each point grows up or populated, and after population, you can check that whether you are getting a line on this point, whether you are getting a point or you are getting a surface. So you can find out the nature of the image. I have given an example. In left hand side, it's a noisy input. Now look, if you look at the input, the image is not clear. But when tensor voting takes place, we will get the image which is on the right hand side. So this is the main object.